Good afternoon, everyone. So please take seat because we are just about to start the session. Okay, my name is Fernando Perez. I'm the co-chair of this action, and also I'm belonging to the University of Cordoba and coming from Spain. And I have to announce that our co-moderator couldn't just make it just to be here with us, Luca Falasconi, but we have a very good replacement. So Zeynep and Eren, coming from the Ataturk University from Turkey, will just be as a co-moderator with me. Yeah.
Let me introduce you. Hi, everyone. Welcome to our third session after the lunch. I will be the co-moderator of this session, and now I'm going to introduce Professor Fernando Perez Rodriguez from University of Cordoba. He will give his speech titled with quantification of food loss and food waste. Yes, Professor Fernando, the stage is yours.
Thank you, Zeynep, for the presentation, so introduction. And well, thank you. So I have to start to say that I shouldn't be here, actually. This is the word of other people. I know the leader, neither the co-leader of this VG3. So Natalia and Luca couldn't make it just for being here. So I just going to replace them. I will do my best. I wasn't behind the work that they did. So I just have some gap of the information, but I know Natalia is there. So please, Natalia, be good with me. Because I will do my best. So this is the layout that I have for the presentation. So I will give you an overview of this working group. So I will also give you some overview about the project that they did in the VG3, and the next steps that they are foreseen for the next 2 years. And if you have any question, I will try to answer them as possible. And this is the scheme that we have in the cost action. So as you know, food loss and waste is something that there is a multidimensional problem. So we cannot tackle that with the one side. We have to see all the picture. And one of these dimensions that we want to tackle is this quantification of food loss and waste. So you know, and those especially that are applying for Horizon projects, that there is some request and need of generating data to know how much we waste, how much we lose through the food chain. So this is the main focus of this working group. So the approach that they are doing is a very nice and very novel approach, because they want to use the citizen sciences to contribute to this quantification of food loss and waste. So one of the objectives of this working group was just to use a unified methodology, a validated methodology, just to get this information, and more importantly, to identify those I could say drivers that are behind this food loss and waste. And at the end, just to raise awareness. So just to engage with all the actors in the food chain. So this is one of the important things, but finally to recommend how we have, what we have to do just to prevent and to mitigate food waste. So at the end, we are doing networking, yes, with excuse, but not as really excuse to get data from food waste and loss. So the starting things that they did was first, something that maybe we are not aware, but the definition is really important to define what they are referring with food loss and waste. So So they define first what is food loss, and in order just to more precisely to estimate food loss during the primary production, which is one of the aim in this working group. So as I said before, they wanted to follow a unified or standardized way to get this information. So they, based on current methodologies proposed in different frameworks, including the European regulations. So they adopted this framework for getting or collecting the data. And also they did the same for food waste. So that at the end, it's really important to get this definition because the data will depend how you are defining them. So they also define food waste. So we wanted to collect data at different steps because of this definition. So from primary production to, I would say, food consumption. So this is the main aims that we address in this working group. So these ideas, this discussion about the definitions, about the approach, about this standardized methodology were put on the table in a training school that was organized by Natalia in Canfield University. I can say that this training school was a success training school, and they gather international trainer from different places, but also so many, I would say, trainees also coming from very different countries. I can see here like 37 participants and from over 10 different countries. So and was a successful event in which they can discuss about the concept and how they can address this quantification in food loss and waste. So this is the plan of the deliverables that we have in this WUJI 3. I can say that they delivered the first one, which is the important one, because it's the methodology that they are going to use for collect the data and to implement this methodology through a survey. And all the following deliverables will depend on the first one. So something that they are expecting to have in the third and the fourth year of the cost action. So let's focus on the first one. This is the title: Design and Implementation of an Online Survey to Estimate Food Loss and Waste from Production to Consumption. It's already submitted. We also have a very good feedback from the reporter, for the evaluator of this cost action. And in this survey, or with this survey, we were able to collect around 93 responses from 23 different countries, just to collecting data about food loss across agriculture supply chains. So they based in these responses, they based in scientific studies, industrial reports, and also field measurements that they probably did in their activities. Some of the important outcomes coming from this survey was that the predominant matrix in which they collect more data was in fruits and vegetables. Probably it's because they are quite perishable food, so that's why they are in the center, in the core of the survey. They are representing the 80% of the responses, and just putting more focus on apples and potatoes. So there are also other categories that were addressed by this survey, and dairy product, meat and seafood products, but we can see that they are underrepresented when we compare the data with the ones for fruits and vegetables. So yeah, another point was that we have this uneven representation across regions or countries. So we have some diversity in the answers that they have, depending on the region and the country. So Natalia just provided me some I could say, the conclusion. So about this data, So first was about the primary production. How is the main drivers, the main factors behind these food losses? So here we have weather extremes conditions, systemic limitation, mainly due to lack of labor or knowledge. And when we go down in the food chain, so in the storage, it can be related to the inadequate management of the storage, but also when we are not able to predict precisely the shelf life is another factor that can be associated with food loss. And behavioral use is always behind these events. Market demand was not flagged, was not highlighted as a key driver in the responses. Though alternative markets could offer some opportunity just to reuse these food loss. Somehow this stress is that we have a gap. Somehow in this pyramid of food loss and waste priorities. So because it's reuse is important thing, but we are missing that in the answer of the different responders. So it means that we are underrepresenting this part of this food loss and waste pyramid. As you can see, we have challenges there. It's an even distribution of the information across the countries. Some of the gap that we just couldn't cover. But even so, I think that we think, and Natalia also thinks that this is a promising step, and that this is a very good starting point, so just to shed light on food waste and food loss quantification along the different supply chains. So let's see in the next steps. So here you have the deliverables that were submitted based on this. Actually, before the submission, they have several meetings and in order to validate the data and to give shape to the data. So this is one of the pictures showing this one of the meetings that they had. So yeah, this is the kind of layout of the deliverable, and just saying that, okay, we covered most of the things that we proposed, most of the tasks that they were related to deliverables. So the first one was the definition, but also how we estimate the food losses, and finally this data coming from this approach. And now, because we've in this deliverable, what I explained, I was just specifically referring to food loss, and there is another important pillar here when we want to quantify is the food waste. Actually, we said that we define also food waste in contrast to food loss. And we have a different approach just to get the information, because we focus on household waste, so focus specifically on that. So Luca was in charge of this important task, and he prepared another survey that was distributed through different countries, thanks to the management committee members that they have a very active, I could say, contribution and participation in this survey. So the only thing that they added in the presentation, this what you have there, is that in some cases we have the limitation of the language when we want to have this survey. So just prepare a survey in English, but at the end, when you go, for example, to Spain, there are some people that can have some difficulties, especially when you are focused on very, very specific population group, which is people that are living in specific houses and so on. So, and they are not scientists, and they are not familiar with another languages. So what we did in Spain, just translate the survey done by or designed by Luca into Spanish, and we also prepare a form to be distributed using the social media, for example. So what you have here is a snapshot of this survey that we prepared. It was prepared also in collaboration with Luis, and that is also here. Okay, so at the end, and this is what Luca prepared for me just to be presented. So we were able to capture the food waste at a large scale In other words, we were able to cover so many responders, more than 1,000 responders across 70 countries, which is I could say a big coverage of the survey. So I mentioned that, or if I didn't mention that, I should mention that is no, I mean, the quantities to get this quantitative data is not the only goal. Actually, this is an intermediate goal to get something really important, which is to know the drivers, which is the root cause of this food waste, but also food loss. So because it's the way that we can get just to help the decision makers to make the right decisions about how we can reduce food waste. So in this survey, they was also identify socio-demographic patterns. So they collect this information, also the lifestyle factors. So we collect this information just to try to correlate the food waste data with these factors as well. And at the end, as I said before, it's not how much is why they are wasting food. Because in that way we are somehow helping to generate informed prevention strategy and policies, which is the most effective way to get the strategies designed. So here, Luca also provided me some key messages coming from the data that they collected. So the household food waste is primarily a behavioral issue. So not only it's a measurement issue. So perception-based surveys cannot replace direct measurement. It means that what we did here is complementary to what is done when we are doing precise measurements of the food waste. Understanding drivers enables more effective and targeted intervention than quantities alone. So again, reinforcing the importance to have these studies plus those that are measuring precisely the food waste. Because remember that what they are getting here is the opinion from the people in the houses. So they are not measuring precisely what they are wasting. So this is a different kind of study. So large-scale cross-country evidence can help design scalable policies. So it means that we have, I could say, would use the expression, the more the merrier. So it means that if we want to be something at a very high scale, so we need to have enough data to do it. So it's representative data. So that's why it's important to have these studies that can cover so many responders. This work supports the shift from estimating waste to preventing waste. This is one of the sentences given by Luca here. What is the next steps? Okay, so we didn't get the whole picture actually for some of the surveys, because I must say that there are some countries which are missing. Even Spain is missing there. So we have to still to work to get the data, especially for the case of the food loss survey. Food loss surveys is sometimes it's more difficult because you are depending on the companies that can provide the data. Sometimes they are not. I mean, they are not wishing to share all the data that they have. So, but still, we are working to get more countries on board, and that we can have a more representative estimation of food loss across Europe. So yeah. So the other things that when we have all the data, we have this finished. So we want to disseminate this information, and the best way to do it is to prepare a scientific publication. So this is something which is in the past that we have in this working group. So very nice key messages also. So what cannot be measured at scale cannot be effectively reduced. So again, so we need enough data to design effective strategy to reduce food waste. This work shifts the discussion from how big might be the problem to how much is it. So what can we do about it? So innovative and positive methodology. So this is the important message that are conveyed here in the presentation. And hopefully we are able to engage with stakeholders. Maybe we can also help to shape the current regulation just to help to reduce also food waste. And yeah, this is it's one of the most recent meetings that they have in order to discuss about the outcome from this service, and also to coordinate themselves to start to work in the manuscript, yes, based on the information coming from the service. So once we have the manuscript done, or when we have the data processed and analyzed, of course, they want to disseminate the information there, because it's the only way we have to engage with others in the food chain, other food actors that are important to convey the message. So they want to organize webinars for industry, for academia, for the government, and to showcase the importance of the quantification and the policy for a real change in this field. And that's all from my side. And well, I did my best just to convey the information from Natalia and Luca. And if you have any question, I will try my best again just to answer your question. Thank you.
Thanks, Professor, with this very extensive speech. We have a time, so because the second presenter is, I think, is missing, right? Yes. So if you have any question or recommendation to Professor Fernando Perez Rodriguez, please welcome.
Okay.
Yep.
There.
Thank you very much. My name is Laszlo Albronco, and I'm inquiring about the target audience who needs to respond this query. So just in the scientific network, the scientists or other stakeholders who really have data, or what the responders think, what is the waste in different stages of the value chain. So what is really the target audience where we can widen this? What do you think?
Yeah, good question. So probably you are referring to the first survey that we are targeting the food loss. In this case, we think that we have to integrate all the information that are out there, but we are also aware that the most, I would say, precise information could be in the hands of the companies. So that's why it was one of the targeted, or the main targeted population, or target population that we have here. So, but then we didn't, as far as I know, we didn't exclude other data that we can also complement the survey. So, for example, in the case of Spain, we are contacting companies, but also we are getting information from national reports to be included for whole sectors.
I think there is no question. Okay, thank you, Professor.
Okay, so as Ned said, so we unfortunately we are not going to have with us Luca. So we have to skip this presentation. I did my best just to convey some of the information that Luca could collect from the survey. So that's why we jumped directly to Zeynep. Zeynep Eren is coming from the Atatürk University from Turkey. Zeynep is going to present the work with the title "Quantified Food Loss and Waste in Turkey: A Critical Step Towards Achieving Climate Targets." Zeynep, the floor is yours.
Thank you. Hello, everyone. I am from Atatürk University. I work over there as a professor and also office coordinator of the climate change. Dear Fernando explained very well about the food waste. I'm going to take your interest into the food waste management in the point of environmental engineering perspective. Of course, with the case study of my country. Turkey has changed the country names officially as Turkey, as in our mother language, but still we use both of them. So sometimes I used Turkey. Sorry about that confusion. So today my goals are to highlight the critical gap in food waste management, focus and data in my country, and also to argue for accurate official data collected through specific scientific papers, household surveys, field studies, actual waste generation audits, and also official reports from national or international organization. And also to demonstrate that only with reliable data can we effectively manage, reduce, and valorize our largest waste stream, food waste. And finally, to show that by closing this data gap, we can unlock the true potential of food resources and build a more resilient and circular system for my country. If you look at the figures behind this global crisis, food loss and waste, there are three main concerns. One of them, food waste is a global challenge with direct impact on climate change, resource use, and food security. It costs $1 trillion American dollar per year, according to United Nations Environmental Program official reports. United Nations Sustainable Development Goal target 12 and sub-target 3 calls for cutting in half per capita global food waste at the retail and consumer level and reducing food losses along production and supply by 2030. The second important of the food waste, of course, it's environmental cost. Food waste responsible for 8% of global greenhouse gas emissions, causing the release of methane gas, which is almost 30 times bigger than the carbon dioxide as its global warming potential. Also, it wastes 20 or 23% of agricultural land, 24% of the fresh water, and almost 40% of the energy in supply chain. This information is also cited to the FAO official report. And the last one, of course, is a moral imperative of the food waste. Approximately 1/3 of all food produced is lost or wasted annually, while 700 million people face chronic hunger. We waste 1/3 of our food. In case of my country, there is a big, of course, data lack in the field of the food waste. Turkey is among the top 10 countries globally in food waste. It's estimated almost 8 million tons food wasted annually. That equals to 93 kilogram per capita, according to some scientific papers. We only get the food waste data, not food waste, as an organic waste data, are official statistical institute. It's called TÜİK. Official data covers only municipal solid waste. That means 32.3 million tons collected every year as a municipal solid waste in Turkey. Food waste is a component of the organic fraction, so there is no specific food waste component in it, and it is official data. So Turkey lacks a comprehensive national monitoring system for food loss and waste across the supply chain. Food waste is not disaggregated, excludes losses from production, processing, and also retail. From the environmental engineering viewpoint, we have approached by viewing food scraps as a waste. Of course not, but we called it as a waste to manage it a proper way. Our primary goal has been to manage this waste within the waste hierarchy framework, as shown in the right side of the slide. So waste hierarchy implies that in the first stage, we have to reduce all kinds of the waste. It is the most preferred way. Then the rest of them can be recycled or recovered for the energy. And the final stage, of course, the least preferred one, is landfilling. In the case of the food waste, landfilling causes more greenhouse gas potential than the regular waste because it emits methane gas. So, of course, the waste hierarchy is not the one model. There is also another model, circular economy. According to circular economy model, there is no concept of the waste. They are all just cold resources. We must view food scraps not as waste to be managed, but also as valuable raw materials. In Turkey, we have a zero waste model system, which is launched at 2021 officially. It's mandatory. It's a separate collection system, mandatory but not household mandatory. So the consumer can separate their wastes and collects and bring all these kind of wastes to the receiving center, settled in the city center or in somewhere in the city. So household food waste is not separated, collected in this manner at the source. That means missing the largest potential stream because the organic waste almost constitute more than 50% of all total waste. So we always focus on the rest of them, 40% of them. We always focus on plastic waste, for example. It is a portion, a ratio as a 30% almost, most of 30% in total waste, but we ignore the biggest part as a food waste. So that's the reason I wanted to point out this kind of waste management today. So according of this not mandatory system, the composting rate is very small. It's estimated 0.7 to 1.1 in all recycling system. So that means organic waste, the food waste in landfills contributes to the methane emissions also to the Turkey greenhouse gas emissions. So what is the reason behind the household food waste not composting or not collecting separately? There is a scientific survey. So it seeks the behavioral drivers behind of these low recycling or composting rate. It gives a results to us like three important points. One of them is over purchasing, like 80% of people joining to the survey to answer this question as answer this problem as a over purchasing of the food. And second one is spoilage. It's almost 70% of the answers of the people. And the third one is leaving food on the plate is almost 60%. And also UNEP reports give us important results that annual per capita household food waste and almost 100 kilogram, and also 23 of purchased food is discarded unconsumed food, according to our Ministry of Trade report. Most weighted items are fruits and vegetables. It comes in the first line, and secondly, dairy products. Annual edible food loss and waste, 26 million tons, which corresponds to 12% of the food produced. Largest loss at agricultural production stage. That means that 13 million tons. That equals to 13 million tons. So hidden potential of food waste, that these graphs show us how we manage all food waste, or how we can manage all food waste. There are several ways to evaluate them. First of them, the animal feed production. According to some scientific studies, food waste could reduce annual almost 10 million tons of imported feed in the Turkey. The barrier of this stage, lack of advanced technology and standardization. And second potential is biogas production. We can produce biogas via food waste, almost 3 or 6 billion cubic meter methane gas per year. That means equal to 6% of Turkey's energy demand annually. But limitation of this stage is low capacity used by some large processors. Third one is the compost production of food waste. In Turkey, only 7 central composting plants. There's only 7 central composting plants. Also, they has low quality, underdeveloped market, and economic unsustainability disadvantages. Fourth waste management way is biofuel production. Only 11,000 tons collected out of the 350,000 tons of waste oil. It also has advantages of bioethanol and hydrogen production. It's still under research. The fifth phase is incineration and landfilling. There is no municipal waste incineration plants in Turkey because it has low calorific value. Most of them, unfortunately, 64% of them still goes to landfill area, and rest of them is uncontrollably disposed in somewhere. Also, landfill gas, it has landfill gas to produce energy. In Turkey, municipality has 80 plants to produce landfill gas to produce electricity. It has a almost 200 megawatt capacity. And waste management and economic potential of food waste costs 10 billion Turkish lira in municipal waste alone. Also, it has also energy from it costs energy from agricultural animal waste that meets the 22-27% of the total consumption. So I try to sum up all these waste management methods in this table as a current situation in Turkey. So as you can see in this table, all of waste management method for the food waste are very limited or it has low capacity to sustain the process, but potential is ranked by high and medium by very high. So we can evaluate all food waste in a proper way to give some advantages as a resource, material, or energy. There is a success story also in Turkey as bread waste prevention campaign. It is launched at 2013, and it has achieved the 18% reduction in the bread waste since it's first launched. That means total economic contribution is almost 3 billion Turkish lira. Additional annual indirect saving of 2.5 billion Turkish lira from changed consumer behavior. It is also recognized by FAO as a global best practice. Finally, of course, we can manage all food waste to contribute our or every country's climate targets. Food waste is a critical barrier to Turkey's climate targets, as in many countries. One of the main problem is the lack of the reliable data. So if Turkey's commitment to achieve net zero emissions by 2053 as reducing emission by 41% by 2030. So comprehensive food waste management and recycling can directly contribute on the order of 5 or 10% to national emission reduction targets. So that's all on my presentation. This is my some view of my university and also my city, Atatürk University, and my city is Erzurum. Thanks for listening to me.
So thank you, Zeynep, for your presentation. So now time for questions. We have time. We're there.
Thank you, Zeynep, for your wonderful presentation. As a Turkish citizen, I'm aware of some of the problems that you have mentioned, and I took note of, we usually say research gap, but you said research black hole. So not knowing even where to start is a problem, maybe. But would you say that education is a key way of tackling this, because household waste, the best way to limit it is
education
with
is the
education, and
yes.
So it's even beyond the physical sciences, and it has to be tackled with education.
Of course, education is, I mean, a primary issue in every field, not of course the waste, only waste or food waste. I just try to point out the waste management, food waste management as an environmental engineer. Are you environmental engineer?
Food engineer. Food engineer from Akdeniz University.
Is there any environmental engineer in here? So,
Thank you.
I hope it,
No,
I mean,
specific
gives a
question,
different idea to all people, like summarize like general framework of the food waste management.
Thank you very much.
Thank you too.
Another question? If not, we can close this session, but before moving to the next one, so we have a housekeeping announcement from Gianfranco.
I saw that room became a little bit, so maybe after the good lunch, somebody slowed down a little bit. So, no, thanks to the efficiency of Slaven, where he is wrong. He already shared the pictures, the group pictures that we had this morning, and some of the smart people in the room already posted and reposted it. So it is, Marwa placed it on all social media. So feel free to share because it is a way also of communication of our activity. And there on that post, we will place all the pictures that we have first. Second, if you, since cost is a public, everybody with mobile, is a public project, we will be happy to make available on the COST website all the presentations that are already or will be on this computer. So we will grab from this. And of course, feel free if you have to delete some slide that is already in the internet because it is shared on Facebook and so on. But if you want to delete some slides from the PDF, feel free to send to the address costfoodwastestop@gmail.com the presentation in PDF, the updated presentation. So we will replace the one that you showed. Second, we have over 60 posters. So even for the posters, if you can send us the PDF, we will upload on the website. It is a good way also for dissemination of what you are doing and what we are doing all together. So thank you, Fernando and Zeynep, for this session, and welcome Sandro and Marwa, I think, for the next one.
Hello, everybody. So we will start this session with Sandro Frati, that he is the work group leader, number 5. He will present for us the activity of work group 5, cross-cutting strategies and smart system for food management. So Sandro, the floor is yours.
Yeah, thank you very much, Marwa. So my presentation will be most of all about the activities that are planned, because they didn't start yet in this case. So please don't expect an extensive big list of data, because that is in the near future. Didn't happen yet. So yeah, the focus area of this work group to talk about the topic is indeed cross-cutting nature, address the cross-cutting nature of food loss and waste. So the focus area is state of art of digital tools to improve food capabilities, engage customers, optimization of the various activities related to the post-harvest, handling of food. And also a big part related to the regulatory environment. And also you will see later in my next presentation, the goal is also to see a bit, or at least to start interacting with the policymaker to see what could be improved, what would be the point for improvement. So planned focus areas, indeed, and identification of smart technology applications. So we have, I think we are the working group with the highest amount of private companies interested in participating. Analysis of food safety hazard along the chain, socioeconomic drivers, and like I was saying, guidance of for policymakers and regulators. So like I was saying at the beginning, the activities of these working groups are in this moment in preparation. So, well, I'm the chair. There is a co-chair, which is Clara Montesinos. I don't know if she's online in this moment. Anyway, we will reach out very soon to start organizing everything with the persons that are interested. For this project, this working group has 4 deliverables. The first 2 are foreseen at month 36, which is September of this year, and other 2 at the end of the project, so month 48. The next ones would be indeed assessment of regulatory framework for food loss and waste, and also for what concerns the smart technologies, protocols for smart technologies, so for processing, transport, distribution. Then in the later stage, we'll be working on biodegradable packaging, and also on a guidance document for policymakers, because the idea is indeed to engage with them as much as possible. So yeah, the activities will be indeed that: engage stakeholders, policymakers, regulators, technology providers. We have in the group quite a number of also private companies that might be interested in in interacting with us a bit more, and also engage stakeholder on social economic impact of this. Expected outcomes, protocols for smart technologies, policy guidance, which is something we need a lot. Let's hope policymakers will be receptive to that. So let's stay tuned. We're going to reach out very soon to start really planning in a concrete manner all the next thing that need to happen. It was a short one, but yeah, it's all about during this moment. Thank you.
So thank you, Sandro. Do we have questions for the activity of work group 5?
Or interest in contributing further with us?
Yeah. Okay, so now we can pass to the presentation of also Sandro about the regulatory framework of plant protection products and biostimulants. Yeah. So.
Good afternoon again. A presentation regulatory after lunch is probably not the best moment. I will try to keep you all awake anyway. So the purpose here is to show a bit some information, some comparison about the regulatory framework for biostimulants and for pesticides. So I will try to highlight the main things in common, the main things that are not in common. Just for information, well, I'm not coming from a university, I'm coming from a private company which is called Triferto. We sell fertilizers, which is not the topic today, but if you're interested, please reach out to me later. So why to register products? Why regulation matters? First of all, to protect human health, environment, also to assess scientifically risk and benefits for the use of a certain product. Also credibility of products and the claims. So the things that the producing company claim that the product does, that's also to be double checked. We will see different legislations, for example, Europe or the US approach this topic in a different way. And then facilitate trade and innovation, because, for example, let's remember, because I guess many of you are more very much active in the field of post-harvest. So when you sell fruit, for example, every time you need to comply with the legislation of destination place. So if you sell your fruit to Canada, you need to comply to the Canadian legislation and so on. So regulation defines the boundary between science and market. So the products, this will be very obvious for many of you, but maybe not for everyone. So just quickly to summarize, biostimulant and plant protection products are very different. They are not to be confused. Some companies do confuse them a bit, but that is not how it's supposed to be. On purpose, indeed. So biostimulants, they act on plant metabolic processes. For example, improving or slowing down certain mechanism. They have then an indirect effect on the plant performance. So for example, in some cases, they might help the plant to be a bit more resistant to abiotic stress, for example. And that has an effect then on the yield, on the quality, for example. They have no direct action on pests or pathogens. When companies purposefully mix things up a bit, is often because a registration dossier for a pesticide is more expensive. So they register the product as a biostimulant, which is cheaper, but then they tell you on your ear, actually it works also on a disease. That's a type of thing that is not allowed. Plant protection products, on the other hand, they have a direct action against something, against pests, diseases, weeds. So they have different biological targets and also very much different type of regulations. So definition of biostimulant, I will be happy afterwards to share this presentation, so you will all have it. So stimulate plant metabolic processes, it independently from nutrient content, because a biostimulant is not a pesticide, but is also not a fertilizer, it's something else. So it doesn't really provide food to the plant, but somehow it helps the plant in some other ways. So for example, improves the efficiency of use of nutrient, tolerance to stress, quality traits, some quality traits of the plant, or nutrient availability on somewhere in the soil, for example. So no pest disease control. Plant protection products, on the other hand, like we were saying, is something that works really directly against an organism, against something. So for example, protect plant or plant products, for example, fruit in post-harvest, that's also true, against harmful organisms. These are the fungicides or insecticides. And on that, we also have insecticide or fungicides that are registered in post-harvest, for example. Another thing can influence plant physiological processes. For example, growth regulators, they are also classified as plant protection products. All preserve plant products. So for example, 1-MCP, which is a gas that blocks a certain aspect of the metabolism of fruits. So those fruits can be stored for longer time. That's also plant protection products. Or last one, herbicides, to destroy unwanted plants. So, and the claim that you do on your product determine the regulatory status. So very important to be really clear on what the product can and cannot do when you develop a product. Legal frameworks, there is a green thing, okay, this is about biostimulants. It's a fertilizing product regulation, which is fully applicable since 2022 in Europe, and now we're talking about Europe. Key elements is a regulation based on product, gives also this CE certificate, CE stamp, and it's all about safety, quality, and claims control. So it's a bit different and is also much lighter than the registration of a pesticide. That's why my comment at the beginning, some companies that don't want to pay a full registration dossier, this one is easier. Plant protection product regulation is still the same, 1107/2009, which I remind is valid for chemical pesticide, but also for biological pesticides. So there is today very long discussion at European level about having quick, easier, shorter way to market for biological pesticides. But today, okay, you can avoid certain studies in certain cases, but the procedure is pretty much the same. It's not really something else. Core principles for Europe, very important, precautionary principles. So very much with the focus on health of people and of the environment, risk-based assessment. And then it's a two-level system. So basically it's a kind of a double registration, if you can see it in this way, because you have to register the active ingredient first at European level, and then you have to register the product. So the formulation that is made with that active ingredient. So it's a kind of two-step approach. It's highly structured and also quite intensive. All companies complain that Europe is one of the most expensive places to register a product. Degree of harmonization. This is very important because well, when I learned this, I was at first was really confused about biostimulants. So in this moment for biostimulants, there is this European legislation I was showing you two slides ago. But in many countries of Europe, you still have national fertilizer legislations. So somehow we're still in a situation in the middle. So if you register a new biostimulant, you can either do it at European level, then your registration will be, of course, valid in Europe, or also register it according to the national legislation of a certain European country. And in that case, of course, the registration will be valid only for that country. So it's still, it's not that harmonized in this moment. It's kind of a double. On the other hand, plant protection product is very much harmonized. So there is only one type of registration for Europe and one rule for the whole, for all Europe. It's a key difference in regulatory maturity, of course, as well, because the biostimulant European legislation came into force only 4 years ago, while the pesticide one is much older. Data scientific requirements. So for what concerns, the weight is really very much different. Biostimulant safety focus assessment. Not a lot of agronomic evidence. If some of you already registered the pesticide, you really have to run a lot of trials. Trials need to be GP, need to be in different climatic zones. So you're going to pay a very expensive efficacy part of the dossier. This you don't have to do for biostimulant. While for a plant protection product, indeed mandatory efficacy trials, extensive other data you have to provide, toxicology, residues, ecotoxicology, fate in the environment, a lot of other tests. Because that reflects also different risk profile. Pesticides are seen by the regulators as something that could be more dangerous if not developed or applied well. So that's why. Time to market is also different. So for biostimulants, if everything goes well, 1.5 years max, you are okay. You can have your registration. Plant protection product can be much more because you have to run many more tests. Also, the efficacy trials rarely all work, so you also very often have to repeat some. And so it's very much different. So then I put some information about other places in the world, just as a comparison. Biostimulant. US, there is no federal regulation today, state level approach. So depending on the state of the United States where you want to go, you might have different rules that apply. Some of them will be very, very quick. Others, maybe you might have to provide extra data. Brazil, there is a national framework under development. So I guess, of course, I cannot see the future, but I guess Brazil will be one of the main first ones to become, to have an harmonized system for biostimulants. Asia, country-specific system, often regulated as fertilizer. So often you just have to, treat the product as a fertilizer. I know for experience for my own job, very often it's just about an import permit, so it's quite light. So it's very different in different places. Then we go to pesticides. In the US, you have a federal registration with the EPA. You might have in certain states a little bit more you have to do. Like in California, you normally have to run 1 or 2 trials, I remember. So, but not much more. In Brazil, you have joint evaluation from different regulatory bodies, different parts of the government, in fact. And in Asia, it's quite heterogeneous still. So you have, of course, you need registrations everywhere, but it changes in every place. So a summary. So for summary of everything I try to say in this time. So for the biological target of the product, for the biostimulant, you have nutrition, stress, some metabolic aspect. For plant protection product, pests and diseases, and weeds, I would say. Your EU framework, you see there, one legislation that is more recent for biostimulants, one that is older for pesticides. Harmonization of biostimulant, not completely. Of course, if you want to play it safe, it's always better to register it with a new legislation, so you're good for all Europe. But I know also situations where somebody decided, okay, I want to sell this product only in Spain or only in another country, so we just abide to the rule of that country. That works for biostimulant, not for pesticide. Data requirement, very, very different, much more limited for biostimulants, and the time to market also very, very different. So yeah, since I guess many of you come from research world, I tried to put a couple of thoughts about that as well. So I think what is very important when you develop something, when you're working on something, to have a very early definition, very early idea of the product claims. So to start to work already from a research point of view, so at the very beginning, thinking about registration, which need to come later. If you're successful, if you start to collaborate with a company or something, that will come. Scientific evidence must match regulatory category. In best case scenario, that would be great. In some cases, innovation might be constrained by a regulatory scope because you might have a certain trait that will make a new invention very difficult to register in the future. For example, I remember when you work on microorganism, if the microorganism can survive at human body temperature, that's normally something that can pose a very, very big problem for regulatory purposes. And also, of course, that would be great, increasing interaction between research and regulation. So I think we can say that regulation, maybe we can argue that should not be like that, but I believe it is like that. Regulation influence, I think, has an impact on research direction. So yeah, conclusions, biostimulants, plant protection products have a different use. So when I hear otherwise, I'm always skeptical. European plant protection product regulation is fully harmonized. Biostimulant is a bit less. And understanding regulation is essential. And that's it for my regulatory show. Thank you very much.
Thank you, Sandro. So we have time for question. I have, okay, yeah, you can, there is some, yeah, I will ask after. No, yeah, go. The microphone.
I'm sorry, can you repeat? But there are some plant protection products registered for post-harvest use. Yeah. You mean bio? Mm-hmm. No, no, but there are post-harvest products. I mean, plant protection product registered for post-harvest. Yeah. Well, there are chemicals that are still registered. Imazalil, for example, is also still some Yeah. But what do you mean by bioregulation? Biostimulants? No, biostimulants, they're for field application. Because no, I would say that everything that works on the metabolism of a fruit today is plant protection product. Like one in my example, 1-MCP, which is a gas, it's regulated as plant protection product. Biostimulants, they are more for the field. So I'm talking about both here. No, as far as I know, no. At least not a commercial level. Biostimulants for post-harvest use, no. Because when like in post-harvest, I guess we're mostly talking about fruit or vegetables. Yeah, you don't have a live plant anymore. So the effect of working against stress or against these kind of things is a bit less relevant than with a plant that is growing. So personally, I don't have. I know that a few people tried, but as far as I know, that was not successful. Yeah.
Okay, just curiosity. So you mentioned that firstly we should like register the active ingredient, then the product. So if the active ingredients are like approved and registered, is that sure that the product will follow that result or not?
Well, in theory, no, but in practice, yes. So what will happen? So you register. That will not be the university. Yeah, you will partner with a company. You will register the active. Then there will be a formulation. For example, what I would always advise is also for the formulation to design the formulation based on regulatory requirements. And there, yeah, at the end, eventually it will always be registered. So based on how it is, what the regulators want to see, in certain cases, they may ask you for some additional studies, additional data. But then at the end, yeah, you will be able to provide everything they want, so it will be fine. Normally, what you do most of the cases, once your product is ready to be registered, you ask for a meeting with the authorities, and you start to show a bit informally what you plan to do, what you have, what the features of this product, and they already give you a first feedback. For example, they might say, I don't know, yeah, this part is not that characterized. Can you do some study more on that? Or maybe in some cases even have a comment on the composition. Maybe there is a component that they see as problematic, so they can give you a feedback. I think eventually you always will register the product.
Yeah, so if we are speaking about the time that taken for registration, so I think it take more time for the active ingredient to be registered than the product, yeah?
More or less, I would say it's the same, because with the product, you also have to do all the efficacy part, which is normally at least in 2 seasons, different seasons. So for example, if something to be applied during the fruit growing stage, that would be in different years. And then you need to have a efficacy part that is complete enough. And it depends also, there is also certain element of luck in a way, because sometimes you have trials that don't work out for reasons that are not problems of the product. For example, in some cases, it's a very common story that there is no disease pressure in the site where you run the trial, so you have to do it again. So, yeah.
Yeah. Okay, thank you, Sandro.
Thank you.
Do we have other question? No. Okay.
All right,
you.
thank you. So next up, we welcome Wang Yi from University of Bedfordshire, UK, with a presentation about intelligent systems for food waste management. Yi, the floor is yours.
Yeah, not yet.
Almost. Still yours.
Anyway, grazie signore.
Prego.
Okay. Dobar dan, kako ste? Puno hvala što ste mi pozvali. I am Professor Yi Wang. I'm from University of Bedfordshire, UK. For those of you who don't know where it is, it's about 20 minutes with train from central London. And today I'm going to talk a little bit about how my research regarding intelligent system work around food waste management. Okay. Yes. Okay, so a little bit about background. So after the meeting in Cordoba, Tyson, myself, Leah, and Victoria cooked up a plan to kidnap Gianfranco and Fernando to write a Horizon Europe project. And this kidnapping went very well. We actually passed the first stage of that proposal, and that is why I'm here to talk a little bit about the project, not the kidnapping. This we can talk during the dinner. So I'm going to talk a little bit about this project, and I'm going to talk about overall. So my background is in sensor fusion and data analytics. So I start to work on the sensor or the merge of sensory data as early as 2006 in a US-UK defense project. This is one of the largest research projects that take place in UK, around $200 million for over a year, and it was extended for another 100 million for another year, run by IBM and MIT as a core, but also UK universities such as Cranfield, Southampton, and I was research fellow in Southampton, where we developed a comprehensive system for sensors, hardware, and software integration. And I've done a little bit of similar work ever since. And since 2016, I work very closely in agriculture, and especially with China as well as with other partners in Europe. So some of our project regarding lookups as Maria Curie Rice scheme, we our University of Bedfordshire led the REMIT, another big data project in Interreg, about €5 million regarding the using sensors for analyzing data alongside agriculture supply chain. So what is an intelligent system? I think we need to get that in place. I think people frequently mix with smart system and intelligent system. So typically an intelligent system has a higher level of analytics and higher level of data management from both systems and also the analytics perspective. So for a key intelligent system, there are at least 4 characteristics that have to be in place. So one is sensor. In other words, you need to have sensors, cameras, or all sorts of data reading electronics. The second is reasoning. In other words, softwares, systems that allow you to understand and perceive data, identify the behavior, and make sense of behavior. The third is decision support. And the fourth is adaptation and changes based on the behavior that is already existing. For those of you who are familiar with intelligent system of sensors. This is the robot on the top. Top side is one of the first ever intelligent system developed at MIT. This robot was developed in 1978, around that period. And the down there is the our very new sensors or intelligent system for food waste, which is developed in 2019. Now the question is, why such a large year gap between the one and the other? Mostly is the hardware and software alignment. At that time, 1970, all the hardware and software are very expensive and not accessible. Now it's more available and allow us to do the research required for gathering data. Yeah, do stop here. I tend to speak much longer than needed. And so the idea with the whole system is that you have a hardware software integrated system that can allow a better understanding of the environment and system it belongs to and integrate into a better system. Now, I do apologize if you are biology or bioscientist or any medicine or pharmaceutical background. My presentation will not have any pictures of rotten apples or fertilized fungus or anything. As a matter of fact, I don't think there will be a word in there that starts with letter B. But it is important that we have your samples and we have your detail used as a base for any kind of analysis. And that's where the intelligence system is from. So we need data, we need reasoning system, we need further decisions. So the top end of managers, like those who sit in the EU, those who sitting in the government, who don't have technology training, are able to make the right decision and able to adapt as the world changes quite quickly. So as many of you have heard this morning, there are huge challenges within the area of food waste and how can we manage it properly. So the project that we're doing or where we are currently quite interested in is from a household waste perspective. So you manage and deal with household waste at food waste at household level. Okay, so this it might be easier to deal it at a restaurant, hotel level, but at the end of the day, it's individual household seems to be a much challenge, but a much needed use of the policies and regulations. And also there are other reasons like GHG emissions, resource loss, economic costs, as you are all aware, and the traditional long-term behavior is always difficult to grasp. And it is something that we need to do. And by current research, by current development, we are able to do that. So we are in the era of fourth industrial revolution, going into the fifth industrial revolution. Maybe some of you have heard of that. Typically, we talk about the agriculture 4.0, or 5.0, as we're going toward the fifth industrial revolution. The idea is automation and sustainability. Okay, these have to go hand in hand. We do have achieved automation in some area of the world. So for instance, we have about 5 O2 ports in the world where you detect everything automatically. So the biggest in Shanghai, there's 5 million containers going around every day, and there are only 4 people deal with it. The second is in warehouse. So we can achieve automation from a practical and conceptual basis, but can we achieve that in household food waste as well as general food waste from that perspective? And this is what I'm interested in, and this is what we hope to achieve. There are quite a lot of already existing research regarding the intelligent systems, such as typically on monitoring, prediction, and intervention. As you can if you are research in this area, you know that there's a new algorithm come out every day, and a new method come out every day, and we require a proper way to evaluate which is good or which can be more intertwined. And previously, and when I say previously, about 5 years ago, I mean, from various research indicate, not various research, also Horizon European Commission indicates that we are very reactive. We need to be more active. Okay. In other words, rather than let things happen and then react to it, we need to really go ahead, as we have plenty of tools to predict accurately or to draw a snapshot of future, so we can better forecast what is happening in the future and use that as a base to develop something useful for human beings and for the system. Okay, let me just do a little bit of what exactly we're doing. Oh, sorry, that video is not running. Right.
Sorry, still 2 minutes to go, please.
2 minutes to go. Okay.
Sorry.
Okay, so this is partially what we've done. Currently in the market, there's a very clear, or there's a already standard setup. If you look at the left-hand side, that's a standard setup of an intelligent waste bin that have been used to detect waste. So typically on this bin, you will find a top level where we have the sensors, sensor systems, where in the middle you have various databases that deal with the various data that can be sorted. And this is where artificial intelligence is. And here there's an algorithm called ULO. It's common algorithm. It's based on deep learning. In other words, neural networks. Certainly we can use other networks or other machine learning algorithms. And we create an overall database or knowledge base that's able to feed up to a phone, where we have apps where users can identify what they're doing and can change their behavior based on the trial. So this is already ongoing. What we want to do is improve the overall system. So a couple of years ago, we started a big project with China regarding the sorting of the food waste. So this is one of the prototypes that we use and currently use in several regions around Shanghai area, where we have different sensors and integrate them into this into one large system where you can monitor and sorting out different type of wastes. Okay, so food waste, there's wet waste, there's non-wet waste, there is some waste that can be used to fertilizer, some waste that cannot be used to fertilizers. And we have used that base as for the change of the development of this kind of intelligent systems into managing. And behind that, there's also a huge complex analytical algorithm that integrate everything together. So to do it quickly, for our project, we are I know there are competitors in the room, but I take a risk to share this knowledge. I think knowledge should be shared rather than held against the So we're going to use several bins, and we're going to use cloud system to gather this data, and this data will be developed or analyzed by developing different patterns, and this pattern will be linked into system dynamic models, and we are going to use this model as base for policy. And this will be co-developed where we're going to feedback to the original data if it is missing. So almost done, last page. Yes, I think that's 2 minutes.
Few seconds, actually, it's okay.
Questions?
Thank you. Any question for you?
I hope I didn't scare everybody on this, but I know there are competitors here. You're very welcome to ask questions. I mean, I might choose not to answer, but depend on the question. when you say rich, you mean buy or so the idea is that you have an idea what you are actually throw away and whether you can be conscious on what you are making. So for instance, the idea is to harmonizing the waste gathering system, or the waste data gathering. That's first. Second, each household, if you use it, you will have a clear nudge or an intelligent nudge to know whether you are overproducing or underproducing, whether your waste can be saved or the direction of the usage. I mean,
But still not making money, don't worry. All right, so, but there is also the coffee breaks in case you can interact there. Thank you so much.
okay.
And please just another technical communication. Please, those who have ordered the posters and have not paid it, Jelena will now be in front of it. So please provide payment, and also those who still have to deal with the social dinner, Jelena is outside, so please do it.
And please, we invite all the speakers after the coffee break to upload their presentation now.
Okay, good afternoon, everyone. We are ready for the last session. So I hope you still have some energy left. We are going to present the activity of the working group 4. So we are doing one step back from what we heard just before the coffee break, because we were hearing the planned activity of the working group 5. The working group 4, it's focus on the valorization of the agro-food waste and a circular bioeconomy. So it's very much related and taking advantage of the outcome of the working group 3 on the quantification. I am leading this working group together with Victoria Krauter, that is not here in presence, but she's connected and she's following us online. And first of all, I am repeating myself from last year, saying that the working group 4 is the one with majority of the members. We cannot see fully in the slide because it's partially covered, but we have 657 members on around 900. That is the total members that we have in the cost action. And we are covering 53 countries on 63. That is the total amount of countries that the cost action is covering. I try to summarize in this slide the numbers according to the country. And also in our working group, Turkey is well represented. I would say half of the people that are contributing in this working group are coming from Turkey. But we also have Spain, Serbia, Portugal, and Italy quite well represented, and we have anyway members coming from other countries that are also active despite the numbers that we can see here. In this slide, I have, and we can see the overview of the tasks that are expected to deliver in our working group. So we have 6 tasks that are directly connected either with the activity, either with the deliverable. The first 2 tasks in particular, they are going to be addressed with the specific activity. The first activity that we can see here, the establishment of effectiveness on bioconversion of insect, it's something that Sarah, my co-chair in this session, is presenting in a poster. So I invite you to take a look at the poster, because this poster is going to open the door for a potential publication next year. And Sarah will talk more about this in a dedicated working group session that we will have tomorrow. Then the second task, it's something that we are considering to address. First of all, thanks to the training school that we are planning to have this here in Latvia, and I will tell something a little bit more later about this. While the task 3, 4, and 5, they are directly connected with the 3 deliverables that we are working for more than 1 year now. And the last task, it's something that we are going to address with the last deliverable that is not started yet, but we are planning to start very soon as one of the deliverable that it's ready, it's officially submitted. So we will open another call for this last one. And coming to the deliverable, so here are the title of the 4 deliverable. As I said, 3 of them are ongoing. And actually, the second deliverable, that is the deliverable that have the closer deadline, it's ready to go. So we soon will have the feedback from the core group, and then we are able to submit it in the system. The first deliverable is very important because it's giving us the structure of the training school as well. And I will not develop much on this because Laszlo, the coordinator of this deliverable, is having a presentation after me about this. The third deliverable, as the other working group, almost all of them, we are also expected to have review papers, in our case on valorization. And this is something that we are working on. And the last deliverable, yeah, it's something that I will open the discussion with the working group members tomorrow in our session. Regarding the structure of our working group, we follow the structure concept that the working group chose first initialized. So we also established 4 different subgroup with different section dedicated. So the vegetable, where Sarah Milliken is the coordinator. The fruit, where Özgür Taran is leading the activity. The cereal, Victoria is taking care of coordinating the group. And then a subgroup that currently is not active anymore. It has been incorporated with the cereal due to the fact that the members in that subgroup were not able to meet up regularly, so they were not able to match the activity. And after some internal discussion, we decided the best way to keep the active member in that group was to incorporate it in another group, so they had the chance to contribute and keep up with the activity. Regarding the role of the coordinators, they are organizing internal meeting and coordinating the task independently. And regularly we have a meeting where I have the chance to receive all the update from the different group, and is the moment where we are incorporating the different activities done in the core deliverables or what we need to prepare. The aim so far of this structure was dedicated to the preparation of the first round of deliverable. So again, here I'm listing the 3 deliverables so we have worked this year. And I am also mentioning the coordinator of the deliverable, because we understood that there was a need of support of the coordinator of subgroup to work properly on the deliverable. So Laszlo is the actual deliverable of the first, the actual coordinator of the first deliverable, and Enrique together with Doenita for the second deliverable, and then we have several coordinators for the third deliverable because we have several ongoing review paper. I'm mentioning Sarah in the first and the second deliverable because she's giving a strong support in terms of contribution. So she is actually considered by each of us also part of the coordination, not just of the vegetable subgroup, but also of the work in the deliverable itself. What we have done in 2025, well, I already mentioned the regular meeting that we have. This is something that we are trying to be very strict, because it's important for all of us to keep the line. Otherwise, we are all get lost in the main our job, and we are leaving the activity of the cost action behind. But in this way, we have at least once per month the time to bring the focus back there. In end of May, beginning of June, we have organized the first session of the webinar series of the Food Waste Stop. And here in the slide, you can see the title of our webinar. It was a good success, in my opinion. We had a very nice comment and review after it. In October, with the coordinator of the first 2 deliverable, we understood that we wanted to reopen a call for contribution to finalize the document, because we already had at that time the document almost prepared and ready with all the contribution that came during the previous months. But since we decided to have annexes also, it was just nice and fair to reopen the call to involve the members that maybe were joining later the working group, so they were maybe not fully aware about the activities ongoing. And in this way, we actually receive a lot of more contribution. And thanks for this contribution, we actually reach this point. So for the first deliverable, we have the deliverable itself ready, and Laszlo is going to go a little bit deeper in the content of the deliverable a bit later. And together with the deliverable, we have 2 different annexes. We have a collection of case studies, plus a collection of implemented solution. So thanks for everyone who contribute in this sense. We received a lot of material, and we are happy to keep it open to receive even more. Our idea is to upload these documents together with the deliverable itself in the repository of the website. So this is going to happen soon. We already pre-agree that with the core group. So you will be informed when the moment arrives. The second deliverable, as I mentioned before, it's ready. So here again, I put in this slide the screenshot of the first page of the deliverable itself. In the deliverable, since Enrique is not here, just to give you briefly the idea of the content for the ones that are not familiar with it, we have decided, since the task was to have a list of bioactive compounds extracted or produced from fruit and vegetable waste, we decided that the best way to address this task was to provide an up-to-date list of bioactive public database. So we are listing in the deliverable this specific database and describing them, what it's possible to find there, which are the limitations, and how much they are updated, and so on. We have also a section with the most significant publication that are listing bioactives. And also we open a session where we are listing one more time the patent database. With all these three main sessions, we worked on an Excel file table where Doenita at the beginning framed the table itself, and here you can see which are the information that we wanted to compile in this table. We decided to not have everything, what's not even possible to imagine to put all the fruit and all the vegetable here, but 20 selected raw material have a dedicated sheet in the Excel file. And for each of them, we are addressing all the information that you can see here. And this is also something that will be uploaded in the repository, and you will have access on. And in our opinion, it's a very interesting starting point for a potential future work. It can be expanded, it can be strengthened. There is space for working with this, but for the sake of the deliverable, it was not needed to go deeper than we already did. So yeah, you will see what we have done so far, and you are free to comment and come back to us about your opinion on this. Regarding the review paper, so again, each subgroup is working on different paper. In this slide, I have summarized which are the title that are proposed so far and which is the progress. In the subgroup fruit, we have the higher amount of review paper ongoing, and actually one of these review paper has been accepted. So this is a very fresh news because I just received 2 hours ago a message from Osgur that the third title, where the author are listed here, it has been accepted in journal Food and Bioprocess Technology. So it's a very happy news, and even Gianfranco didn't know. So it's something new for him. Yeah, and so we are proceeding, also with the review. We have this last deliverable that is still pending. The task here is to develop at least 4 potential applications of the valorization of the agri-food waste, with a focus again on fruit and vegetable in particular. The very starting of the brainstorming here is to potentially elaborate the case study that we have collected within the guideline in the first deliverable. But this is an open discussion that we will have tomorrow. And then it will follow up an official call for it in a Microsoft form, like we did in October 2024 for the very first call. And something to decide here is if to work as a unique body or if to work separately, as we have done so far, and then put together the material from the different subgroup. But again, this is something we will have time tomorrow to discuss. One big challenge that I have within the working group for this year is the organization of the training school. It's almost ready to be open for the invitation of participants. So as Gianfranco already mentioned this morning, the official call will come through the newsletter. So keep an eye on the newsletter. Don't miss this chance. Here I am listing which are the main topic covered, and these topics are the topics that we are elaborating in the guideline. The period it's also set, so it will happen from 26 to 28 of May, and it will happen in Cēsis in Latvia. I don't know if you have ever been even in Latvia or in the Baltics, but I tried to put the bullet point about Cēsis because it's a very small village in the central northern part of the country, but it's very easy to reach in a way because it's only 100 kilometers far from Riga, the capital, and Riga it's very easily accessible with in the airport. We have a very big international airport, and the public transport in Latvia are very efficient and very cheap. So I think from the logistic point of view, there will not be any issue. And here it's the very draft agenda of what is potentially the program of the training school. I don't know if you can read anything there, but well, there is still some speaker to be confirmed. But in general, the topic and the structure of the event is here. But yeah, this will be available and much easier to read when you will receive in the newsletter the call. And with this, I think it's all from my side. I want to thank you again one more time for all the contribution, because without your contribution, all this work would not have been done. So I'm very happy about this. I'm very happy about the collaborators that are teaming up with me in coordinating all these tasks. So thank you.
Are there any questions for Jessica? No? Well, you can always catch her later.
Please come tomorrow to the session that we have, because we will have a lot of things to discuss. And we are meeting at 5, if I'm correct, or 4, I don't remember, but well, it's in the program.
No, after lunch, I think. Before lunch, 12 o'clock.
Before lunch, so yeah, don't forget what I said. So yeah, let's meet according to the program time. And okay, so now.
So our next speaker is Professor Laszlo Branco from the Institute of Food Science and Technology in Budapest.
Thank you, Sarah Jessica. Dear colleagues, so today I'm going to give you an update. As Jessica mentioned, one of our deliverables, it is a guideline about valorization. Okay, just to give you a quick context, this is work group 4, which focuses on valorization of agri-food waste and circular bioeconomy. And we had a task relating to that to give and elaborate on new strategies. And that is deliverable 4.1, a guideline for new valorization strategy. And the goal of this document is not reviewing the current strategies, but to give highlights and or highlight the challenges, what we found, and give some insight and further input for elaborating more detailed strategies. Okay, it started practically in Córdoba, when we started actively working on that, and it should be finalized very soon. I would give you just a quick timeline, what we have done so far. As you can see, all the milestones in this evolution, and we are here today with the second draft, which is finalized. And I would like to give you an overview of this guideline, and rather just focusing on some key areas in that. So this is the actual title. So guideline for valorization of fruit, vegetable, cereal, and animal product processing side streams. So 2 things, what we have to conclude so far, that it is really a wide focus on various types of input materials. So it's not only fruit or only cereals, but a rather narrow focus on the location where the byproduct is generated. So we discussed and arrived to that conclusion that manufacturing of food and beverages or food processing is the target location where we want to focus. And the reason for that, because according to Eurostat, this is the second largest portion of food waste, if we call it like that, next to household waste. And on average, it's close to 20% of the total food waste. And the key advantage on focusing that the production of this, or the generation of this food waste is generated in an industrial settings, in a very controlled or more controlled environment. And it is continuous and reliable, centralized supply. So much more easier to handle, not sporadic like the household waste. And traceability and predictability is again easier to follow on. So we focused on that portion of food waste, and some key areas of the document. We did a review of the current landscape and identify the key challenges. Of course, the first one was the terminological ambiguities, like everywhere. And in food processing sector, the waste, this expression, it's not compatible with food, with many regulatory aspects, because you cannot use waste for food. And in this sector, food waste is rather considered that material that is discarded. And so it's not a good expression. That's why we thought it is much better to use byproducts or side streams of food processing. And we came up, of course, with some proposed definitions, but at the end of the day, what is the key message from that guideline? That yes, we can call side streams byproduct, and we gave some details on that, and even co-products you can call these, but from a regulatory compliance point of view, it would be the easiest if we just call them products. So let's say if you produce cheese and whey, then you have two products, cheese and whey, and none of them are waste or byproduct, co-product. Okay, another key area is valorization, to approach it as a multi-step value chain. What do we mean by that? Of course, there is a zero step or the very initial step to avoid loss and waste according to other kind of policies. And when we talk about valorization, it means that we give value and a new perspective for the residues or these unavoidable byproducts. And so just to give an example, we find in literature and in many aspects that when we extract a valuable high value compound from a byproduct or a co-product, then this is valorization. And what we think, it's not enough to call it valorization. It's a key step, a prerequisite, but also it needs some other steps. So we need a much more holistic approach. We need appropriate collection if we really want to move forward for a large scale feasibility, and rapid stabilization, because traceability and to address all the hygienic and safety issues, it is very important to set up appropriate collection workflows and rapid stabilization workflows. And then once you stabilized this byproduct, then it is you can use transformation, extraction, what is quite often found in literature. And then you have to make a market-ready secondary product that you can sell to biorefinery companies, because otherwise, if you have just sporadic byproducts, you cannot set up an appropriate business model for that. And we also highlighted that the thing that we have to avoid, if it's possible, the premature energy recovery, because there are higher tiers valorization pathways. I will get back to this soon. And what is also very important, to design the downstream integration of that secondary product. So altogether, this is what we call valorization. So it's not enough just to find a target in your byproduct, but let's design the downstream integration of that. And when it is realized, then you actually valorize the byproduct. And in accordance with other policies, instead of reacting to that, that's what to do with that waste, try to design from the very beginning how to valorize that. Okay, and this is another aspect what we addressed in the guideline, the multi-purpose valorization or zero waste approach. Again, when we extract something that we think would be a high value component of the byproduct, actually we generate a secondary byproduct, the residue that we have after the extraction. So what we suggest to use the same approach, try to avoid loss and waste during that extraction step, but there will be unavoidable byproducts, and then follow the same protocol for downstream integration. And we also introduced to this guideline the concept of hierarchical valorization. it means when we design valorization pathways, we need to validate the target end uses using some key criteria, including the sustainability impact. And just to break this down, the energy use, the footprint of this valorization pathway, we should use life cycle assessment, and maybe let's consider the baseline as the landfill of this waste when we treat it as a waste. And we also have to emphasize the societal aspects of the impact of sustainability. What is the population size that benefit from that valorization? Maybe if we make just a very fancy product like an upcycled ingredient into a biscuit, or to do compost from that byproduct that can be beneficial for a much wider population. So this is also an aspect. And we also introduced another aspect is the preservation of the biological complexity of this biomaterial, how to efficiently use the resource, because once it is created by using land as a very limited resource, then try not to burn it, let's say for biogas or something like that, if there are possible higher tier pathways. And circularity is also an important criteria. What we can also call in this context the food system proximity, that we try to retain food byproduct in the food system to make it the circularity better. And of course, we cannot avoid the economical value potential. And we introduced a decision-making support for the food system proximity or the circularity aspect. The top tier is food upcycling, because when you use a food byproduct to valorize in food, including food ingredients like functional ingredients. The second one is feed applications, because feeding is the closest to food system, because you feed it to animals that can create food for human consumption. And also insect rearing can be included into that tier, because if you cannot feed it directly to animals that can produce food, then you can use an interface, the insects, for that. And then plant and soil applications in this tier, the third one, because then you still keep the byproduct in the agricultural system and enhancing the more efficient land use. And then the last but one is non-agricultural application like cosmetics and something like this, or biomaterials. And here we thought that priority should be given to food packaging, again, to keep the proximity, the close proximity to the food system, and then energy recovery. However, we also added some key amendments to this hierarchy. The first one, that maybe the lower tier valorization can be more sustainable, okay, and economically more practical. And we also realized that the current policy here in the EU, that subsidizing energy recovery is making the economical potential higher for energy recovery, but it's a biased thing. So because it's subsidized, and I mentioned that it is almost in the bottom tier, the non-agriculture application. However, we should know that, let's say, cosmetic or nutraceutical application, they have very high economical potential, and maybe they can create the framework for a biorefinery architecture. So it can be also very useful. So to sum it up, it means that we have to use multi-criteria value assessment tools for the appropriate pathway. And we also covered some regulatory aspects in this guideline, the novel food regulation, food safety regulation, and even ultra-processed food aspects, but I don't go details right now into that. And as Jessica said, we set up some annexes to the main document, 2 types. The first one is case studies. It is a few pages description of how to valorize a certain type of byproduct based on literature review or personal experience of the contributors. And there is a structured template prepared by Sarah for that, which addresses particular questions. And if someone wants to contribute, it's quite easy to follow. And then we have a nice overview of that case study for a particular byproduct. And so far we have 10 case studies ready. Here you can see that, which are ready. It looks like these ones. So it's really a few pages document. Follows the structure. It contains some literature references, and ideally not just extract from a single paper, but it's still not a review paper. So in between, something in between that is easily digestible, a 4-page for those people who are not deeply involved in this area. And the second one, the second type of annex is industrially implemented solutions. It is really a very short 1-2 pages document to introduce companies, existing companies or projects who actually valorize food processing byproducts at an industrial scale. It is very important. It's not about laboratory scale, proof of concept, but real valorization. And what is important that how we agree that it is maybe not good to involve directly representatives of those companies who make a description like an advertisement of their company, but it's a non-commercial information leaflet, as it looks like this, with some actual companies. As you can see, many of them, we have 26 so far, but there are still many other companies waiting to be introduced using this template. We also have a template for that. And also, as I mentioned, more interesting case studies are still welcome. So we still welcome some other contributions. And finally, I would like to acknowledge all the contributors to the guideline and contributors to the annexes, and Jessica, Victoria, and Gianfranco, who made the framework and let us work in this context, and of course some financial acknowledgement. And I would like to thank you for your attention. Thank you.
Thank you, Laszlo. Very nice presentation. I think you really gave the overview of the work that have been done. I'm afraid there is no time for question. I let you go despite the time because it was important to reach the end. But now I am inviting here Russo Daniela. She is a researcher and associated professor at the CNR, Istituto Officina dei Minerali, in Grenoble, Materiali, sorry, in Grenoble in France. And she will give a talk about interaction of polyphenols with a biomimetic membrane system.
Hi, everybody. So I am a biophysicist based in large-scale facilities, the Institut Low-Langevin, where is the neutron reactor, produce neutron for science, give access to large different spectrometer that you can use, previous proposal acceptance of project. So today I'm going to show what we can do, some of our results. And my joining the cost give me like a great opportunity to have access to a very important molecule extracted from the food waste. And some of them I was very interested in particular polyphenols. Polyphenols that can be used as a drug delivery in cosmetics. And I was interested in how the polyphenols and the different structure of or even concentration of a solution of polyphenols can interact with the cell membranes. How the composition property of different source of polyphenol extraction can impact again the membrane. And this, of course, in the first stage we did it with the biomodel. So we create a lipid membrane with DMPC lipids and adding some cholesterol. Polyphenols, they can interact with the membrane, with the head, the lipid heads, which are hydrophilics, or with the hydrocarbon lipid chain. And we can easily, well, not easily, but we can have access to very nice information. I will show you using neutron reflectometry, for example, which give information on the surface, as I'll show you later, or using small angle scattering, which provide information on low resolution structure in solution. So we can have access to shape interaction of this molecule without doing crystal or using crystallography. In this cost action, I met my collaborator, Laura Aldino, who is in the audience. She provided us with a very nice sample of polyphenols extract from wine cane, Pinot Noir, and Fetesca alba, so white wine, and from mushroom, Boletus eduli. So we have these two sources of extract. We had either raw extract containing protein polysaccharide. We also had purified, because for our need, I'll show you later, the purified was much better. How you can see in the table that in the table, the content of the polyphenols in the purified was much higher. And then it's also very important that we had a very large amount of material, very attractive quantity. We first did some absorption, just because we wanted to be sure that we were working with the different kind of composition of this polyphenols to see the impact on the cells. So this is a simple spectral of the UV spectra of the two components. You can see that the polyphenol extract from the white cane, they're very similar, different from the Boletus one, which present an extra peak, which is related to DNA, RNA, cellular presence. The typical peak are 278 and 320. It's similar for the two wine cane extract, and relate to tannin or resveratrol content, which is missing eventually in the Boletus. So this picture, this test was really to put in advance the fact that the content of the two extract was different. And then the important things was also like to do some dynamic like scattering, where we saw in the raw extract the presence of very stable nano component. So this nano component, which I have a size of 150 nanometers, that are also very stable for both extract. And then they are most likely arising from this interaction from polysaccharide and eventually proteins in the mushroom, or even some aggregate in the tannin. And this is what's the reason why we decide, and I push a little bit Laura to purify this raw extract to get rid of the protein, the polysaccharide, and just have polyphenol. So in our experiment, we will only have polyphenol, a combination of polyphenol, but no protein, no polysaccharide, no DNA, so no extra molecule. We create the membrane, so it's a DMPC with some cholesterol. DMPC is over there with polar head, tails. And for the first experiment, so we create solution of this vesicle with 160 nanometer size. And in order to do the first experiment, the reflectometry one, I need to create a bilayer on a structure. So the solution was treated as I described, was perturbed, and once was injected in the on the silica wave, they collapsed on the bilayer. So why neutron reflectometry? So this is a neutron reflectometry because it's a technique that give information on the surface, can have access to deep molecule embedded in the membrane. So you can also have information about something which is buried. You have information about the roughness and then the composition. So if you add something on a surface with this technique, you can know if it's staying on the surface, if it penetrate, and all these things. So it's not destructive. Is sensitive to hydrogen and carbon, all the elements that we have in this biocomplex. This is a layout of the instrument. I'm not gonna stay on this, but this is maybe is the figures of one of the part of the instrument. There is a bank where we put the sample, and then on the left side is a detector. So what we probe in the reflectometry basically is what we're going to analyze is the ratio between intensity from the incident beam and then the reflected beam. The beam can go from the bottom or from the top. It depends from the choice of the moment. But so this is what basically we do. And from the reflectivity, which is the intensity that we collect the detector, the analysis give access to a parameter that we call scattering density, but it's not important to retain this. What is important is to retain that this parameter is sensitive to the composition of the membrane. So basically the variation of this parameter will tell us if there are objects and where there are, with a resolution of 1 angstrom. So the first, this is an example of the data, the raw data that we have. We work in a different condition in order to enhance the contribution from the different sides. And this is just an example of the fitting quality, just to show you without modeling and stuff. So this is our reference. So here we have the membrane. This is the reference that we have. And on the side, we have the parameter that I was telling you, the scattering length density, and the variation of this parameter is telling us what is where. So here I put some error, and we can see that we have some bump. I'm sorry that I'm not close to the figure, but we have some bump that they can be related, that are related to the inner head. Then there is a deep place which is related to the hydrophobic chain. And then there are the outer head and then the water. So, and this will be our reference. Any variation with this figure will tell us where the polyphenol eventually go. And here just a table which is telling us that, for example, the thickness of hydrophobic part of the membrane, it's about 32 angstrom. The outer head, the one that it's on the top, it's 5 angstrom. And then the one that which is close to the surface is 10 angstrom. And there are some hydration water only on the bottom side. The roughness is always the same, so it's kind of like the fluctuation of the surface. The first example is the white wine. So we did a different concentration. We injected a different concentration of polyphenols on the membrane. There is not much variation. Oh, unfortunately, there is the bar over there where I'm saying that, for example, the second figure is giving information on the polar head position. The third one is giving information on the wall membrane. Because these three figures are in different water or heavy water or a mix of the two. So this is very important for neutron. I don't go into the detail, but it's a very important feature of the neutron. Here is my first model. When I add the polyphenols from white wine, so how you can see the blue curve compared to the dashed one. The dashed one is the membrane, the bare membrane. You can see that there are differences. There is a shortening of the tails. There is a change on the surface. And then the table on the close, you can see that, for example, the chain, they go from 32 angstrom to 25 angstrom. This means that adding polyphenols, there is something that happened to the membrane. Some lipids are extracted from the membrane, there is more space, and then they're squeezed, basically. There is an extra layer. These polyphenols, they penetrate into the first part of the membrane. They do a layer, and then they kind of like arrange on the top. This is the white wine. This is the Pinot Noir. The last figures is just showing you that the kinetic of the interaction with the membrane, it's quite fast. We didn't see any difference after the injection and starting of the measurement, which is about 5 minutes, basically. Here it's our the same figure. So how you can see always the dashed one is the bare membrane, and then the thick one is the Pinot Noir. So with the Pinot Noir, there is a thicker layer on the top of the membrane, still penetration and extra lipid extraction. So basically those polyphenols from wine, they're not very nice with the membrane, at least with this model of the membrane. So they kind of like disrupt, and then they insert very stable into the system. Those are polyphenols from mushrooms. First figures are always the same than before. Polyphenols from the mushroom are very similar or quite similar to the bare membrane. And then the analysis of our data is suggesting that they're just sitting and interacting with the surface of the membrane. They don't perturb, they don't extract any lipids. So, and also the tail thickness, it stayed the same. After the reflectometry, we tried together to other things basically, but to do some small angle scattering in solution. With small angle, how I'm saying there, it's giving information about size, shape, interaction of this molecule. Those are typical example. Also in this case, I'm not going to the fitting modeling and stuff. I'm just trying to describe very qualitatively the figures. This is the spectrometer we use. It's 40-meter small angle scattering of the Institut Langevin. I think it's the best science in the world available today. This is, for example, a comparison of the two. In one side, wine, and then Boletus polyphenol interaction with our membrane. Already, the part that they are in the circle, what they're saying is that basically the polyphenol from the wine, they create aggregation. They clustering, they push the membrane to cluster somehow. And then in very high concentration, we also observe precipitation. So basically breaking apart of those vesicles, which didn't happen with the Boletus for some reason. So really the composition of those solution was very different. Light scattering also confirmed that there is a difference between the size of those polyphenols on the vesicle. The peak which is there is also very significant and behave differently in the two cases, because the shift of this peak is telling us that there is a difference in the thickness of the vesicle. It's shifting with the white wine, it's not shifting with the polyphenols from Boletus. And finally, the highest part, the difference in intensity is basically a fingerprint of the fact that the membrane with both polyphenols becomes more flexible, soft. This is because the insertion of the interaction with this with the lipids, it's kind of like reduce the ordering that the cholesterol is given to the membrane. So, and then there is also an enhancement of the hydration. So the highlight is basically polyphenols from wine, extract from wine cane, are interacting. They have an affinity with the hydrocarbons of the membrane. Hydrocarbon of the membranes, they are able to pull those lipids from the membrane and hydrating the membrane. Very high concentration is catastrophic, believe me. Yeah, I'm done. Boletus is only interacting with the surface. It's more gentle and then can be eventually considered for application. And now we are also considering the impact of those polyphenol with bilayer which are charged. With that, I want to thank the ILL for the being time. And in this cost project, we had 4 peer review and approved proposals. Next deadline is February the 15th, and we think to submit again 1 or 2 more proposals. I want to thank Laura for all the work for the polyphenols. And there are 2 new projects always in the context of the cost. One is to produce some nanoparticle, polyphenol nanoparticle for drug delivery, and the investigation of the extracellular vesicle produced from plants and their interaction with the membrane. And this is always in the optic of drug delivery. Thanks for your attention.
Thank you very much, Daniela. That was it was quite highbrow for this time of day. I'm sure there must be some...
Sorry, I think I killed everybody.
Are there any questions? We don't have time. Okay.
It's okay.
All right, we're out of time. Thank you very much. Okay, so our final speaker today is Lorenzo Guerini from the University of Padua. He's an associate professor, and he's going to be talking about the valorization of distillery vinasse.
Hello, good evening, everybody, and thanks for being still here. I will try to be fast, and I'm going to present mainly a case study. Okay, the trials we did in the attempt of scaling up a laboratory procedure into a actual industrial extraction plant. The case study I'm going to present is related to the distillery vinasses. Distillery vinasses comes from the winemaking process. And just to give you an idea, winemaking generates a large byproduct streams. In fact, roughly half of the processed grapes will become byproducts. These are what remain at the bottom of the fermentation tank after the winemaking. These account for from 6 to 12 grams for each hectoliter of produced wine. And for that byproduct, distillation is a law requirement, so it's mandatory to distill wine lees. So lees are brought from the cellar to the distillery, and in the distillery, valuable extracts are recovered. These are ethanol and tartaric acid, but they account only for the 10% of the initial mass. The remaining 90% are vinasses, and they are disposed, or in the best case scenario, valorized as into biogas plants. However, within this vinasse, there are still valuable compounds, particularly polysaccharides and beta-glucans and proteins that are discarded with the remaining part of the vinasses. For that reason, my colleagues developed extraction protocols to recover these compounds. And this was very good. You can see the paper. But that extraction procedures relies on laboratory equipment, and in particular, they relied on a pressurized stainless steel tank named autoclave. Now, to have an autoclave into a process mean high temperature, high pressure, an expensive and batch-based equipment, mean that it's difficult to integrate it within the distillery process, and also it is subjected into too strict regulation. Okay, this is exactly the point where many ideas, where many protocol stops. We were here, and so we try to did these experiments in order to overcome some of these issues and to propose a reasonable industrial setup. Okay, I repeat myself a little. The overall aim was to prepare for scale up of the protocol, generating the data required to design the final plant. So we wanted to generate these pre-engineering data in terms of physical properties, density, specific heat, viscosity. We want to quantify how the different fractions of interest behave under changing extraction conditions. And based on this information, we designed the process and we selected the most appropriate equipment. Okay, here you can see our experimental plan. We had 3 variables: percentage of solids, 10, 30, and 50%, time, 20, 40, and 60 minutes, and temperature, 104, 108, and 112 Celsius degree. Please note that all these temperatures are lower than the autoclave condition. So we introduced 2 benchmarks. One was the autoclave, 121, 20 minutes, 10% solids. And the other one was the untreated vinasses. We measured the polysaccharides with chromatography. We quantified the 3 fractions, high, medium, and low molecular weight polysaccharides, as well as the protein. And also for each of our suspensions, we measured density, viscosity, and specific heat. we modeled all these results using a response surface methodology to find the eventual point of optimization for the process. As a result, you can see that how molecular weight polysaccharides was recovered at their best in not treated vinasse. So time and temperature damage them, leading to their breaking into medium and low molecular weight polysaccharides. So here, if you are interested in this fraction, our best option is to separate them immediately after the distillation. In terms of medium molecular weight polysaccharides, we were able to find a recommendation, a recipe. Our maximum was reached at 104 Celsius degree, 20 minutes extraction, and 50% of solids. The same a recommended recipe was also found for low molecular weight polysaccharides, as well as for total proteins. So, merging together all these consideration, we found how to shape our recovered fraction according to the extraction condition. You can note here that the autoclave condition was never required. Also, we found that the viscosity significantly increased with the percentage of solids. And it changed from a low viscosity to a medium viscosity. 90 millipascal per second is roughly a cold oil. Okay. And here you have our consideration made according to this result. The first consideration, I think the most important one, is this one. Since pressure was not required, we removed the autoclave and we move to a cooker operating at atmospheric pressure. Here you can see two quotations from the same companies. And as you can see, we move from 140 to 45,000 euro, just to have removing the autoclave. In addition, although viscosity were not excessively high, during the trials, we noticed that vinasse showed a strong tendency to fall on the cooker wall. So we decided to introduce a mechanical stirrer, a mixer, to homogenize during the extraction, preventing this fall. And the next design decision, I will tell you in the next conference. Okay, here we have our proposed plant layout. So the vinasse were first cooled. Cooling them gives the opportunity to recover the maximum amount of high molecular weight polysaccharides, to recover the heat, and to decouple the extraction from the distillery stream. Then we, after recovered the high molecular weight polysaccharides, we use a cross-flow microfilter to concentrate the suspension with the following extraction made with the specific recipe according to the fraction of our interest. And okay, this is an example. This is a case study about how some simple experiment could be of a huge help in designing the process scale up. So thank you for your attention, and any feedback is more than welcome. If you need more details, wait, we have a paper, you can read it, you can read them on that. Now it's the time.
Thank you, Lorenzo, very much for your presentation. Sorry for interrupting you, but we are totally out of time. So I actually have questions, but I will reach you later in the social dinner or tomorrow or wherever. So I think we are ready to close for today our session. I'm leaving the microphone now to Slaven. If any communication need to be added here.
I just want to remember that the bus for the dinner is leaving at 7:30 from the location you can find on the desk, reception desk, who haven't taken it till now. As some of the people told that they will come by car, so we can't wait for all. So please try to be on time for the bus. Thank you all for being here today. Thank you for those great presentation. I hope that organization was good enough and that there was not too many problems today. And I will see with all of you coming to the social dinner. If not with the others, we will see tomorrow morning at 9 at the same place. And we'll start with the second part of our BP4. Thank you very much.